conversations.
We need help them too.
We're about to go over some stuff. Alright,
Alright.
so
I'm ready.
I should not hear dice being rolled in my class.
They fail.
No. You've been rolling them multiple times throughout the class period.
They fail. No, I'm
No.
shaking them in my hand.
It's practice.
Okay.
Practice makes perfect.
Practice may make it perfect, but this is a math class where we need to focus on Algebra 2 with stats. Alright, so let's start here. Group 6. Can you give us an equation for part A different than this one?
X plus 7 equals 18.
Say it one more time. X plus 7
equals 18.
is equal to 18. What is that equation saying?
It's saying the youngest child is also 7 years younger and the oldest is
Is that
7
what?
years older.
No, Bree, you would add the youngest child's
No.
age plus 7 years to equal
Listen
the
to
oldest
me.
child. You just
So,
said this 3 times.
Look at this and pay attention, right? This is a different equation, but I like what Anaya is saying here. If I take the age of the youngest child, so remember the context, and I add 7 years to it, do I get the age of the oldest child?
Yes.
Yes. Right? The oldest child is 7 years older than the youngest. That's another way to interpret that. Did anyone get a third equation out of this? Go. Take some notes if you didn't pay attention, or just pay attention and be respectful to others. Pay attention and be respectful to others. Did anyone get a third equation for part A?
Let me hear them.
What you get, Rossi?
You got 5 plus x equals 7. I mean, wait.
Part A. Yeah, part A.
X plus 5 equals 18 plus, 18 minus 7 plus 5.
Okay, wait, so x plus 5
Yeah.
is equal to 18 minus 7
Plus 5.
plus 5. That's different. What do y'all think about that?
Oh, that's smart,
You
man.
must have added them together.
Oh, big.
A and B.
Look, we originally had x is equal to 18 minus 7, right?
5 plus
What?
9.
So if you add 5 years to the youngest child, to make these two things stay the same, you got to add 5 to this side as well?
Well, you
Does anyone know what that's
subtracting
called?
from that side, wouldn't it?
What's it called?
You did learn this last year. Say it again.
Equality.
It is an addition property
Equality.
of equality.
Yes, sir.
Equality.
We're going to go into these details more later, but please hear me very clearly on this. You are probably used to just saying, whatever I do to one side of the equal sign, I gotta do to the other, right? But what does that actually mean? That means that I am using a property of equality because I want the equations to be,
Equal.
oh,
The
not
same.
equal, the same, but do they look the same?
No.
So what is it when they look different, but they're still the same?
Equivalent.
They're equivalent.
Let me see.
So we added 5 to both sides. Is that going to maintain an equivalent equation? Think about it this way. We already know that x is supposed to be 11, right? So 11 plus 5 is equal to 11 plus 5.
Yep.
Is that still the same solution for
Most
that
definitely.
equation? Most definitely, right? It is equivalent. All right. So I like that. That's great. That's not the one I was thinking about. Does anyone know another one?
18 minus.
Give me what you think.
18, you're saying over here, minus x is equal to 7. Because if I take, what is that 18 again?
The oldest child.
The oldest child minus the
youngest.
youngest child, I get,
You get their age difference.
you get the difference in their ages, right? The difference in the age of the oldest and youngest is 7,
See, I had that.
Uh-oh.
right? Are there lots of ways to write equations here to represent the same idea?
Yeah.
Yeah, all right. What about part B?
Oh, y plus 5 equals m.
No.
Interesting. Tell me why you use the y there.
Because that's the youngest child.
That's the youngest child. Braden, why do you think he used m on the other side?
Middle.
Because that's the middle child. Most of us are just saying x and y, but come on now. Use a variable that makes sense for the context. I don't even need to define those variables because it's very obvious based on the context.
I got you one.
Otherwise, you need to define it. Okay, you got one more. Give it to me.
X plus 5 equals 2.
What?
Oh,
Bree, that plus 5.
Oh, no. 11, no. Am I the right one?
No, it's M plus 5.
you're on the wrong one.
It's okay.
It's on B.
While Bree tries to figure it out, does anyone have another equation?
Right here, right?
M minus
M plus 5 is what? I said it already.
Well, Kyron just said m minus 5 is equal to y. Which one is it?
He said minus, we said plus.
And you also have plus. Which one is it supposed to be?
Rock, paper, scissors.
Rock, paper, scissors,
That's
rock.
not how that works. Remember, the middle child is 5 years older than the youngest. 5 years older than the youngest,
Oh,
right?
plus.
So,
You adding it.
Oh, hold on, wait.
but here, that means that the youngest is
5 year
5 years
subtract.
younger, subtraction from the middle child, right? There's one more equation I think could be very easy to base off of this. Does anyone know what it is?
Could you do m plus y? Or minus y? I think that's what it was like. Yeah.
Okay, what do you think would be m plus y or m minus y?
I just had it in my head.
X.
And minor y.
Why?
Why would it be minus?
So let's say you get
Middle.
the age difference.
The
The
middle.
age difference, right? We already know that the age difference is 5. Okay, cool.
I got
Anybody have any trouble with number 2?
Yes. Everybody.
Everybody have a little trouble with number 2? So let's look at this one together. Tyler thinks that the relationship between the ages of the children in family B can be described with 2m minus 2y is equal to 10, where m is the age of the middle child and y is the age of the youngest. Okay? So I believe, Brayden, you already worked this one out. What'd you do with this?
I added 2y to both sides.
Can we add 2y to both sides of the equal sign like that?
Yep.
No.
Yes, you can.
I feel like you can, but at the same time, it always sound right.
So right here, what did we do?
Coming from like,
I added 5 to both sides.
We added 5 to both sides, which meant that that equation stayed the same. We got an equivalent equation, correct?
but 10
Is
doesn't
this
have,
going to be equivalent?
10 doesn't have the variable.
Well, hold on, but just in general, can I do this?
Yep.
Yeah.
Yes, right? That will give me an equivalent equation.
Would it be 10m equals?
Hold on one second, before we get there, hold on.
Wait a minute.
Okay? So that will give us an equivalent equation. Does anyone know which property we just used?
I don't know, I was gonna say inverse, but it's not.
Huh?
Inverse.
We did use an inverse with this
Of
property.
equality.
Which property of equality?
Addition.
There we go. Oh, that's all I want you to recognize. We added, and we did add because it's the inverse, but we used the addition property of equality. Now this is important. What would you say is happening right here?
They cancel out.
They cancel out. That's what everyone says.
I'm at.
What does that mean though?
It means that you basically just got rid of it.
Yeah? But think about mathematical terms and numbers. What is a negative
These
2y
terms.
plus
It was
2y? That's a 0. I didn't just cancel it out, I made a 0 there because, hey, what is 2m plus 0? 2m. It's not just, hey, I canceled it out. I created a 0 there so that I could focus on just that 2m. Now, you were concerned, yeah, can I add 10 and 2y together?
No.
No.
No, they ain't like terms.
So you gotta write them separately. They're not like terms. Also remember, the y, sorry. What's happening between the 2 and the y?
They may multiply.
They're being multiplied, which multiplication is repeated
Addition.
addition. So that's really 10 plus y plus y. I'm just gonna shorthand it. Yeah, I can't add those together. So I'm just gonna do either 10 plus 2y or 2y plus 10. Alright, Brayden, what'd you do from there?
I divided both sides by 2.
So you divided this by 2 and this by 2? Is that gonna be legal?
No, you got to divide it, and I ain't know.
Well, I know, but like looking at it, I mean, is that a property of equality?
Yeah.
Yeah, which property of equality?
Division.
Division. I divided everything on the left-hand side by 2, I divided everything on the right-hand side by 2, so that should work to create an equivalent equation. Notice, what is 2 divided by 2?
Yeah.
That's,
It turns to a 0, so it's just a m.
it turns to
So,
a 1.
oh,
What you
one.
talking
It's a
about?
1. Notice, I said what is 2 divided by
I forgot.
2, right? It's not just canceling out, I am creating a 1, because what is 1 times m? M. That's where the m comes from. It's not just, hey, I'm canceling the 2 out, I'm creating a 1, so 1 times m is m.
Okay, so, hold on, wait. When you just end up with m equals y plus 5?
Correct.
Since-
Because I want you to remember, you know how you can distribute with multiplication? Division is just the inverse multiplication, so you can also distribute with it. We're distributing that division by 2. 2 divided by 2 is 1, so I've got 1y. 10 divided by 2 is?
5.
Hey,
Okay,
is that the same as one of the equations we got earlier?
Mhm.
Oh, Yes, ma'am.
Trying to say that wrong.
Okay, can variables cancel out? So where like they just completely disappear? Or
You can
just
create a
numbers?
0.
I mean with just variables, like not the numbers but just the variables, like
I'd have to look at an example of what you mean. I'm not sure. Think about
I'm
it.
saying like you like the 2. If it was 2y plus 10 divided by 2y, would you still keep the y's? Would you like y squared
Okay, so you're saying 10 plus 2y.
divided by 2y? Like would it be like y
So
squared?
don't forget,
or
you have to
x squared?
distribute, right? So then you would get this. And what is 2y divided by 2y? That'd be a 1.
What I mean is like would you square the
Square.
Where?
You're dividing,
Okay, never mind.
She asked
right?
me.
Now you can simplify this, 5 and 1, until you get, but notice you'd be left with 5 divided by y. The only way you can ever completely get rid of a variable like that is when you subtract, because you're going to create that 0. Okay? Really quickly, I do want to show you this. Hey, you notice that last equation we created over there on the right?
Mhm.
The m minus y is equal to 5?
Yeah. Is that simple?
Can I double both sides?
Yep.
So then I get 2 times m is 2m minus 2 times y is equal to, is that going to be an equivalent equation?
Yep.
So that's the way I could have done it as well, is just take that equation and use what property here?
Distribute.
I ended up using distributive, but right here, what did I have to use before that?
Multiplication.
Multiplication what?
Property.
Property of
Equality.
equality, right? In order to create an equivalent equation, you got to use a property of equality. You got to use one of them, okay? Let's continue forward. All right, I want to give y'all, let's go with 4 minutes. Nah, let's just go with 2 to 3. On your own, independently, not talking to anyone else in your group, just solo, are any of these equations equivalent to one another? If so, explain your reasoning. So take some time to think about this completely on your own, and I'll give you a little bit of time to talk with your group. Are any of these equations equivalent? Think about the ideas that we just addressed and discussed heavily. Do not ignore the ideas we just talked about. She hasn't told me whether they're equivalent, and I'll make sure she's wakes up before we take notes. You haven't answered the question. The whole question is, are these equations equivalent?
Explain
You haven't told me why yet.
Justify.
Hey. I can play the one.
You good over there?
Yes, ma'am.
How about both y'all?
They all have the same answer. Now, you made your life way harder. You had 2 there, but
How?
I want, well, because there's an easy way to do it. I want to point, can I see, actually, right here. You could have stopped right here. You know that, right? Tell me, is that equivalent? So do you have to solve it all the way out to determine if they're equivalent?
Yes, I want to make sure I won't make no mistakes.
But you don't have to. You're already done. That, you used a property of equality, right? Did that give you the same equation as that? Okay. Those are things to think about. I'm just trying to see what you're doing. See if you're approaching it the way we need to be approaching it. Looks like we're all making it harder than it has to be, though.
What do you mean?
Oh, God. What's 15 minus 2?
My knees hurt.
Alright, I was going to have y'all talk in your small group, but y'all all approach it exactly the same way, so we're not going to do that. Which of these equations are equivalent? All of them equivalent. How do you know?
Because I do another 4.
Because A is equal to 3?
Yeah.
Yeah? Okay, but what determines if an equation is equivalent?
If you get the same answer.
No, that's not what we just
If the
said.
answer you get makes the equation true. I mean,
Okay, I mean, it should have the same solution, yes, but that's not what we just said makes equations equivalent. I feel like there's a handful of properties that make equations equivalent.
yeah.
What are those
The
properties?
division and multiplication.
Those aren't properties, those are mathematical operations.
Relative equality.
Say it again.
Relative equality.
The property of equality. Did you know you didn't even have to work it all the way out to determine if these were equivalent?
You get that, find one answer, please.
You didn't even have to do that. Actually, you shouldn't have done it that way. What was the first step y'all took right here?
Subtract this.
Minus
So,
6.
subtract 6.
3 equals
And you get the exact same equation.
Notice what is 6 minus 6?
9.
It cancels out.
Don't you dare say that.
Zero.
0.
You didn't even let me finish.
9.
So 3a is equal to?
9.
And this equals to the second one, which means.
Oh, well, it's not equal to the second
Oh, it's
one.
the
It's
same
the
as
same as the second one.
Don't break it down.
So that means that this first equation
You know you're
and this second
automatically
equation are what?
Equal.
The
Not
same.
equal.
I mean,
We're
the
saying
same.
so they're equivalent, right?
Equivalent.
We got to remember that, okay? 3a is equal to 9, 3a is equal to 9. Notice, I haven't solved this. I just said, I just use a property of equality to see if they were the same. That's all I did. Okay? So, does anyone see any of these equations up here that I could use to maybe figure out if this, or how this equation is equivalent?
Could use it.
What you mean?
Could use it
Would I use the first one, the second, or the fourth?
The,
first.
well, the first and the second, so one of those.
Okay, so the first and second are already equivalent, right? So if I'm equivalent to one of them, I'm equivalent to both of them.
Yeah.
But would it be easier to use this equation or this equation to look at this one?
Two. Well,
You think the two?
What?
So,
why don't you tell us?
I don't know, I want to know what you think.
You do one.
it's
They
short.
do the same thing, you gotta do the same thing, you don't like.
Exactly.
Okay, so you're thinking I should use the first one.
Yep.
Okay, so I'm going to use the 3a plus 6 is equal to 15. But, I mean, am I going to subtract 6 to get to the a plus 2 equals 5?
No.
Can I do what? The third one? Well, that's what I'm looking at. I'm trying to look at
Do
that
the
third one.
second one.
What about
Like,
the fourth
all you gotta do is
What,
divide.
what could I do to this equation?
Divide all that by 3.
Huh.
Can you just solve for 8 and then just plug in?
You gotta divide all that by 3 so then.
Remember, yes, we can solve for the variable. I'm going to come back to you in a second. We can solve for the variable. However, in order for them to be equivalent, that means that they don't just have the same answer. It means they may look different, but they're effectively the same. What properties allow us to create equivalent
The
equations?
properties of equality.
Properties of equality. Dividing by 3, is that a property of equality?
Yeah.
Yeah? Hey, what is 3 divided by 3?
One. So it's gonna be a plus,
No.
Oh, shoot, I think you talking about the other thing you won.
a plus 6 divided by 3 is
So
2.
3 divided by 3 is?
One.
One.
So it's 8.
So 1a. 6 divided by 3 is?
Plus 2. Positive
Which
2
equals
equals 5.
5.
15 divided by 3.
Is that the same?
Third.
So is 3 equivalent to 1?
Yeah.
Is that then equivalent to 2?
Mm-hmm. Which is also gonna be equivalent to
So we gotta
11.
get there. Alright, so also I will point out, couldn't I have just multiplied by 3?
Yeah, but
Oh, yeah, that too.
3a plus 6 is equal to 15?
Uh-oh.
Just gotta use a property of equality to show that that equation is the same as another. Okay, so we know 1, 2, and 3 are all equivalent. Which equation would be the easiest to show that 4 is also equivalent?
the third
2?
one?
Isn't the 2 set up the most similar?
Yep.
Okay, so I've got the 1/3 a is equal to 1, and I've got the 3a is equal to 9. What could I do to one of these equations to show that they are equivalent?
So do
Divide by 9.
I mean, if I take 9 and I divide by 9, what am I going to get?
1.
3.
1, right?
Yeah.
So, what do I still need to do?
Divide
Let me see something.
Divide the other side by 9 because that's the, which property?
Yep.
Equality.
Which property of equality?
Division.
Division property of equality.
I said divide by 2.
Okay?
1/3 A equals
3 divided by 9 is the same as 1/3.
8.
A is equal to?
1. Uh-oh.
So notice the fourth one is equivalent to the second one, which is equivalent to the third and the first. So they are all
Equal.
equivalent, right? Do they look equivalent?
No.
No, but that's the whole point. They look different, but they're still the
Same.
same.
So can we just write all the equivalent of the property of equality?
So let's actually define the properties of equality, but yes, you can just, and I would show using some of those properties of equality, right? All that we need to know is to show that they are equivalent, that they're telling the same story but they look different, we need properties of equality, all right? So the properties of equality, when operations are applied, they must be done so that the equations, equations are equivalent. Same story, but they look different.
Ooh, nah.
We write that definition down.
I would. That property of equality idea is important, right?
Mhm.
And equivalent equations, right? They look different, but they're telling the same story.
Dang, they speak good.
So I want to point this out. Is 3a equal to 9 easier to work with than this first one? But it's still telling the same story. That's why we use inverses with those properties, so that we can deal with a simpler, easier equation.
And nigga puzzle.
To me.
Wait, them up.
Caroline.
Hey,
I mean,
get up
they
for
should-
y'all flaunt. Y'all gonna be in here next semester.
Niggas, yeah.
Hey, I'll be teaching a bunch of Algebra 2 next semester. They can be right back in here.
No, to me, one grade that year.
I just want y'all to know, all 3 classes I teach next semester are Algebra 2 with stats. Y'all want to be back in here?
Never.
Alright, we're going to skip that. Okay, let's take a break for about 5 to maybe 10 minutes so that you can just, 1, have a break if you want, but 2, if you want to ask questions from the homework, this is a great time for that. Alright? So,
That be done.
okay, that's fine. Now, one thing I do want to point out, right, so it's numbers 1 through 4 and then 8. Notice 1 and 2, how it's all about equivalent equations. Hopefully you understand how to do this a little bit better now. Okay, so I'll still answer questions, but number 8's the only one that, as of last night, you should have really been able to do. Honey, you got a question though? Which one do you want to look at? Number 8? Okay? No.
You should have known that.
Yeah, like,
It's a break.
it's not that kind of break. You can chill and just recover a little bit. You can take a nap like some people are already doing, or you can ask nap questions. Alright, for those of us who are interested in making sure that we understand the homework and can do it on our own, this number 8 is a great question to ask. What is the most important word in this problem? The equation matters, there's something else that's more important. Solution. All of those words are actually important as well, but this term solution is the most important. Because what does that mean?
Minus.
No sir, don't you dare say that in my class.
Right solution.
Right solution.
No.
Use the
Equivalent
definition.
solution.
No.
Like, I don't even know what the question was.
What is a solution? When you see the word solution,
Number that made the problem, no, the equation true.
okay, so a value or values that make a statement, a mathematical statement, true. Notice I'm making it more general, right? Because it could be equations or inequalities. So, how am I supposed to use these points?
You put them in the equation.
I put them into the equation. How? What is that 2 going to get substituted in for?
The X.
Notice how this is the x value of that point. So 2 can be substituted in for x. What could the negative 3 be substituted in for?
Y.
Okay, so how would I write this equation now?
2x plus, 2x minus 3y.
So you're putting that 2 in right here,
Yeah.
and that 3 in right here. What do y'all think about that?
Perfect.
Did he put the 2 in the place of the x?
No.
No. Be careful.
3 times.
That is that 2? Is that 3 a variable?
No.
No. That's not a variable. X is equal to 2. 2 needs to take the place of x.
3 times 2 minus 2 times 3.
I will allow you to use the bathroom quickly during break.
Is it break right now?
Yes.
Can I go to the bathroom?
Yes, you got 3 minutes.
Common sense.
Is equal to 12. Does that make sense?
You better not grab it.
Kind of how the 2 took the place of x and that's supposed to be a negative 3. It's taking the place of y, right? Because literally x is 2, y is equal to negative 3. Okay? So is that point a solution?
No. Yes. Yeah. Mr. Kenny, stop doing that.
Ow.
Shoot.
I mean, what are we supposed to do to figure out if it's a solution?
Work it out.
What does that mean? Say it again?
Solve it.
Not solve it, because remember, solve it is to find the solution, right? I don't need to do that. I've got a pretty big expression. I might want to make it smaller or simpler.
Work it down.
So simplify?
Oh.
Alright, simple.
Can I do 3 times 2? Is that simpler than 3 times 2?
Yep.
If then minus 2 times negative 3, that would become...
Negative 6.
No, ma'am.
2.
Oh, you talking about
You said 2.
It's 2.
How many negatives do I have?
2.
So that's going to be a...
Positive 6. Equal 12. 6 plus 6.
12 equals 12.
So is that a solution?
Yes.
So we circle it.
So that's a solution.
He said.
Kanye, does that answer your question?
Yeah.
Okay.
Alright, let's go through
Like
these.
for real, or are you good? Okay. One quick thing, no, you can do the rest from here. One quick thing I do want to point out really quickly is 2, negative 3. 2, negative 3. Why is that interesting?
Because it's
It's what?
on the line.
It's on the line. Wait, the solution is on the line? Huh.
That means they're the same. Or something. I don't know.
Maybe, that's part of it. So we'll talk more about this later, but I do want you to pay attention on this problem. Are all the solutions on the line?
No.
Are all the points that are not solutions not on the line?
No.
Let's work through some of these on your own and figure that out. I'll give you some time to ask questions tomorrow as well if you need to. But try doing some more on your own because you need to be able to do this.
I need to look at this and don't know.
I believe it.
You said you want to do it what, Wednesday?
It is due Monday.
Oh.
Alright, do we need to look at 1 through 4 or do you want to look at it tonight now that we've talked about equivalent equations?
So we got yeah, let's look at it tonight and do it tomorrow.
Look at it tonight and talk about it a little bit tomorrow?
Yeah.
We good with that idea for everybody?
Go.
Alright.
Alright, back on break.
Y'all can take another second or two while I pass this next part out.
I need me some wine. Yeah. You guys some wine? Yeah. I got some.
Oh, you talking about me?
Today?
Oh, yes.
Hey. My dad get walk by, so I'm lonely.
I don't think so. We don't.
Hey Jaden, just don't forget there is a camera filming.
Oh my God. I forgot. You got to get all day.
There's just some things you just shouldn't say.
Did the camera know what they mean?
I don't know. People watching it might.
I said walk.
What do you mean?
I'm just warning you before you start saying dumb things.
Waukesha. You know that?
I have no clue what you just said.
Waukesha? Walk.
I don't think I did this.
Walker.
Alright, just a heads up, the page I just passed out is the next lesson that we're about to look at all together. What I'm passing out right now is the homework that is associated with the lesson I just passed out.
Wait, another homework? I thought we had one.
That's not going to be due until Thursday.
I know it.
You can have multiple homeworks though along the way, but you have until Thursday to complete this homework if you want to make that note on here.
Wait, so one due Monday, the other due Thursday.
Yep. Now you will have other homework along the way as well.
What?
It's all of 6 problems right now until next Thursday.
Is your wife?
Can we all, do we finish early? Can we turn it in early?
Yeah. I was like, I can't imagine y'all doing that, but.
See, don't, yeah.
All right, this last page that I'm passing out, which I probably should have passed out first, hold on. The curriculum that I'm currently using has a summary of each lesson. I will not always have this to pass out as well, but this is a summary of the lesson that we just completed. What is the page I just passed out? What is it?
A summary.
A summary. Why are you complaining?
Who was complaining?
Caroline.
Oh, Caroline. I just called your name. I just like her name sound. Oh, really?
I'm still think I'm doing this right.
We can talk about it tomorrow. All right, let's get started with lesson 7.
I really can't.
I'm gonna be like, yeah. Your birthday tomorrow, girl.
All right, Unit 2, Lesson 7 from Illustrative Mathematics. Braden, can you read our first objective for this lesson?
I can explain how some algebraic moves create equivalent equations with some do not.
Okay, really quickly, because we actually already hit on this. Does anyone know why some algebraic moves create equivalent equations? Does anyone know why some algebraic moves create equivalent equations? Why did this algebraic move create an equivalent equation? That's all I'm saying right there, right? In order to create an equivalent equation, you have to use a property of equality. Hey, Bree, Anaya, it's time to wake up.
My 5 minute workout?
No. It's time to learn some more. All right. Maven, can you read our second objective for us? Hopefully, we already have a big part of that, but we want to know how equivalent equations are related to the steps of solving equations. And someone who hasn't talked as much today, Key,
Hey,
can you get that last objective for us?
Miss Kim, now you know I can't see.
Or you just can't read.
No, I can't see. I got my glasses
All
on.
right. If you can't see it easily from there, Emily, can you read it for us?
I know what it means for an equation to have no solutions and convert an such an equation.
Okay. I do want you to hold on to this last one because I had a very interesting question today where someone was like, well then why is the solution no solution? What does that mean? What do y'all think we mean by no solution?
Ain't no answer.
What do you mean there's no answer?
There's no
There's no way to solve the problem.
There's no way to solve the problem, there's no solution, but what does that mean? What is a solution?
an answer.
No sir, don't you dare! No sir!
Like,
What is a solution?
Any value that makes it true.
a hypothesis has a solution at the end. It's a
Not necessarily. It's a value that makes the equation or the inequality true. You gotta remember, sorry, I didn't hear you. All I could hear was Jaden shouting out was the answer. But an answer can be wrong, the solution is not. So if the solution is the value or values that